Guys, going to demonstrate now response to a student's question about chapter 6. Problem uh, 6, number 5, called sampling and estimating. Okay, click on it. Point out the basic technique is similar to the previous chapter that we dealt with the Kolmar distribution. What's happening is that we have a given text. So we have a bunch of numbers. In this case, there's miles per gallon, 10,000. We know that if you took all those numbers and turned them into a histogram, you have basically a bell-shaped curve and normal distribution. Of 36, measure of spread of the standard deviation is 1.5 now. Now we take a sample of 6 cars, which is usually a small sample, and we test to see how many miles per gallon they have. So one might be 37, one might be 38, one might be 34, one might be 32. They're going to vary, but the average for all 6 of them should be around 36. If you take another 6 cars, you're not going to get the exact same numbers. It might come out to 36.3. And the next 6 cars, the average might come out to 35.4. Take all those averages and graph them as a histogram. The picture will again be a bell-shaped curve with the same middle value, of in this case 36, but the spread from average to average is much tighter than the spread from number to number, because on average, the highs and lows will cancel out. And by the way, all the theory behind this, like the central limit theorem, the standard error of the mean, all that's described quite well, I have to say myself, one of my better lectures, in chapters, the videos that refer to sample distribution of the mean. Anyway, so the question is, I guess similar question. So, a similar question, the average is 43 and the standard deviation is 1.6. Now we're taking 7 cars, right? So the first question is, what's the probability distribution of the mean? What is the shape? Well, I said it's a bell-shaped curve. The average would be the same as the average of the original problem. And the only thing is the standard deviation of the average, standard deviation of the sample mean, which is another way of saying how much the averages bounce around from, how much they deviate from that ideal 43, is equal to the original standard deviation divided by the square root of the sample size. If you want my trusty calculator, we have 7, 6, but multiply it by theta and multiply by 1.6, which is sigma over the square root of n. That comes out to 0.6047. Let's try 0.60. Now comes the probability. Now, in this situation, it will be some, even though the average ideally is 43, there will be some groups of 7 cars that average out to 44 higher. What is that probability? Well, at this point, we're going to go to the calculator that StatCrunch so nicely gives us and use it. 43 is the middle value, but instead of the standard deviation being 1.6, it's now dropped to a tighter distribution of 0.6. So let's do that. Frustrating because I did this 3 times. It's time to get stuck on the StatCrunch. It's not opening. Really another. Let's go to statcrunch.com. similar. There's data. What was that? Okay. Stat calculated. So in our example, the average was 43. Standard deviation was at 0.6, I believe we said. Not the 1.6. But how many are bigger than 44? Two. Answer is a small number, about less than 5%, 0.04779, 0.047, 8. Back to normal. We answer. Get it. Now, what's the probability of sample with less than 41.5? Go back to that crunch. Just change this to a 41.5. Change this to a less than 0.0062. We're done. Okay. By the way, I can help you further about this one here.